In this section, we provide design patterns and architectural options that can be applied in a wide variety of use cases. So the first thing that comes to mind while designing AWS infrastructure is scalability. So systems that are expected to grow over time need to be built on top of a scalable architecture. Architecture such as the architecture which can support growth in users, traffic, or data size with no drop in performance. It should provide that scale in a linear manner where adding extra resources results in at least a proportional increase in ability to serve additional load. So growth should introduce economics of scale and cost should follow the same dimension that generates business value out of that system. While cloud computing provides virtually unlimited on-demand capacity, your design needs to be able to take advantage of those resources seamlessly. There are generally two ways to scale an IT infrastructure, that is vertically and horizontally. So scaling vertically. So scaling vertically takes place through an increase in the specifications of an individual resource. For example, upgrading a server with a larger hard drive or a faster CPU. On Amazon EC2, this can easily be achieved by stopping an instance and resizing it to an instant type that has more RAM, CPU, I/O, or networking capabilities. This way of scaling can eventually hit a limit, and it is not always a cost efficient or highly available approach. However, it is very easy to implement and can be sufficient for many use cases, especially in the short term. Now, the second scaling feature is scaling horizontally. So, scaling horizontally takes place through an increase in the number of resources, for example, adding more hard drives to a storage array or adding more servers to support an application. This is a great way to build internet scale applications that leverage the elasticity of cloud computing. And not all architectures are designed to distribute their workload to multiple resources. So let's examine some of the possible scenarios. So one of the scenario is like stateless applications. So when users or services interact with an application, they will often perform a series of interactions that form a session. A stateless application is an application that needs no knowledge of previous interactions and stores no session information. Such an example could be an application that, given the same input, provides the same response to any end user. The stateless application can scale horizontally since any request can be serviced by any of the available compute resources. For example, EC2 instances and AWS Lambda functions. With no session data to be shared, you can simply add more compute resources as needed, and when that capacity is no longer required, any individual resources can be safely terminated after running task has been drained. Those resources do not need to be aware of the presence of their peers, and all that is required is a way to distribute the workload to them. Now, the question is how to distribute loads to multiple nodes. So, there are two models for distributing load. The one is push model and another one is pull model. So, a popular way to distribute a workload is through the use of a load balancing solution like the elastic load balancing (ELB) service. And elastic load balancing routes incoming application requests across multiple EC2 instances. An alternative approach would be to implement a DNS round robin service feature. So that is like we need to use Amazon Route 53 to enable DNS round robin. And in this case, DNS responses return an IP address from a list of valid hosts in a round robin fashion. So while easy to implement, this approach does not always work well with the elasticity of cloud computing. This is because even if you can set load time to live values for your DNS records, caching DNS resolvers are outside the control of Amazon Route 53 and might not always respect your settings. So due to caching, this can be a challenging job, the DNS round robin feature. However, we can use the elastic load balancers to scale our infrastructure and distribute our loads. Now there is another model, pull model, and that is asynchronous event-driven workloads, and that do not require a load balancing solution because you can implement a pull model instead. So in a pull model, tasks that need to be performed or data that need to be processed could be stored as messages in a queue using Amazon Simple Queue service or as a streaming data solution like Amazon Kinesis. So multiple computer nodes can then pull and consume those messages and processing them in a distributed fashion.